record Taure and then sharing screen. Okay, just give me a moment. Sharing screen. Okay. So share screen, entire screen. All right, all right, all right. Kinogi sigi subject ki matang da kitang kino to si ko minute mga mutang ko. Let us spend some 5 minutes trying to understand the subject and from the exam point of view. Um, Basically, the when you talk about the difficulty level of pure topics, pure mathematics topics. When you talk about the difficulty level of pure mathematics topics, I feel how should I write it? The most hard ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯍꯦꯟꯅ ꯁꯥꯇ꯭ꯔꯁꯤꯡꯅ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯀꯤꯅꯕ ꯑꯃꯁꯨꯡ ꯑꯦꯛꯖꯥꯝ ꯄꯣꯏꯟ ꯚ꯭ꯌꯨꯗ ꯈꯔ ꯀꯩꯅꯣ ꯇꯧꯕꯁꯦꯀꯣ ꯔꯤꯌꯦꯜ ꯑꯦꯅꯥꯂꯥꯏꯁꯤꯁ ꯑꯩ ꯂꯤꯅꯤꯌꯔ ꯏꯔꯣꯏꯒꯦ ꯁꯤꯗꯀꯣ ꯁꯤꯗ ꯑꯩꯈꯣꯏꯒꯤ ꯃꯣꯗꯔꯟ ꯑꯜꯖꯤꯕ꯭ꯔꯥ ꯏꯒꯦ. Basically, I'm talking about group theory and ring theory. Why? Because although questions may seem questions questions are questions have low cost to benefit ratio. As in like low cost benefit sina hene kwai wangi ko. Cost benefit ratio iruno ko. Some people may find this easy, but how should I put it? Kwai dagi hene chana ba wahi je kari no oige doi no. Okay. Linear dum ira se ba. Linear dum ira ge ko. I'm confused between modern algebra and linear. Let me tell you why. I linear dum ilage. Because this is it tests your perseverance, patience, and obviously yes, concepts dum yaw report niko. Apart from your concepts, it tests your perseverance as well as your patience. Why am I writing this? Is because uh, people will say that people will be able to attempt, will be able to attempt. Let's just talk about part C here, okay? Part B, in part C, charokpa 7 to 9 questions ka. Lapakan, the people will be able to attempt around, let's say, 6 to 8. Attempt ko. This gives them a sensation, gives them a satisfaction or a feeling. I would say a false confidence, gives them a false confidence, which later backfires and get only 4 to 5, 4 to 5 correct, or I should say even lesser than that, even lesser than that. 3 to 4 correct. I'm talking about part C, okay? Because the questions will be set for linear algebra will be set in such a way that it tests your perseverance and your patience, means like your each and every option you will have to work on each and every option for sure. This is 100%, because sometimes it happens in real analysis, but this is 100% true for every LA question, LA question in part C. Yan tayo ko Shiniko, that is the sole reason. It tests your patience as well as your perseverance. You may feel that okay, you have done option ahum amadi nang na phajana tawkhre mari dudi nang daw yenge natra madu yaroi ko mari du sun nang kitang hek like thopa kanda upai lete ko because you will get only 3 to 4 correct gyan tai ko hacha the 3 to 4 correct sibok to sena kasi hona ganda ba kanggo di phangoi ko si se ko I'm talking on people who have worked hard ko only the people who have worked hard will be able to achieve this level ko otherwise attempt khakta 3 to 4 lakani ko na tudi ko aduna people who have worked hard would be able to attempt like this and out of this if he or she is not having these qualities then he or she is going to get only this 3 or 4 correct like I said this one is very conceptual everyone agrees very conceptual and yan tayo ko siya aduga sige patience perseverance dum khraga yawi ko very conceptual ko very conceptual as well as you have to be very you have to practice a lot ka practice she's practice to she's practice to, but this has a slightly higher level ka khra khenai ko sinamo next comes the your modern algebra papers modern algebra topics like group theory and your ring theory like I said, these two are like I will tell you how to make this easy if you can if you crack the code then things become very easy ka yes there will be very difficult question one or two very difficult question ka one or two very difficult high tare ka other than way you have to leave these questions yan tai ko ja other you if you have to if you crack the code then it becomes very easy I have kind of like cracked the code ka aduna madugi porto ai aduna ni ko ina sida putra ise then comes the complex analysis complex analysis topic it is more or less easy to moderate question aman idi tum yaw ni ko one or two very difficult you have to see whether this is manageable or not. Aina ngarang takibito ko whether you have to see manageable oibra manageable. You have to see whether this is manageable or not. If this is manageable, you do it. Go ahead. Not manageable, that you leave natra. Otherwise, you leave the thing. Yeah, because this is the how you rank the thing. And then there is also one guy here, number theory. CD pambamina ambataguli ko. Pambamina ambatagwande. More or less for people who are good at modern algebra, they tend to do number theory as well. This is very manageable. Manageable. Ko pamda midi tawda sa kayo kaya day matangda kenogi applied ki pot la ni ko. Now we are going to start linear algebra and I want to share with you how I'm going to do linear algebra. Today is like a basics day. Today is like basics. Basics I think tomorrow till tomorrow basics we yeah till tomorrow maybe till tomorrow. Question kar hapos ay ko haying bugte. I want you to develop this develop the quality of develop the quality of being patient and patient for all the actually this is applicable to all the topics but here linear algebra because question things ko arriba amani khatani atai di sing atani ko you have to be patient for all the uh, options do not underestimate do not underestimate the question plus the options do not underestimate sini ko linear the khwai digi kino tar ko even if you have you know all the concepts you know all the concepts ngasai before exam day before exam let's say like 1 week before exam uh 1 week tokro 1 week before exam tokro see even if you have all the concepts at your fingertips, you still need to be humble enough to respect each and every question, especially especially LA and real. Okay, Yan tayo dyan. You need to develop the, see at the, from the start of my classes, I have talked more on how to develop or more talked more on your qualities that are required to ace the examination rather than the concepts ko. Because trust me, concepts you will acquire in 3 to 4 months. Okay, but this quality, if I don't talk now, it will never come out from you, and you will end up scoring, let's say, around 75 to 80 ka gyan tayo kasi, because you will never improve that idea, that mindset of improving ka si tholo oiba khambra then mind to improve aduna ni ko ina focus yam tawri aduga sigumba LA gumba real gumba di ko it tests you a lot ka not just about concepts ka gyan tay ko hining siya. So aduna sigumba si happy thing can to view develop a personality like this me kana lage. So there are 11 people. Flora is here, Innocent is here, Bubu Sri Lurangamba, Onika, Inubla, Miraba, Sujit, Tarun, Thongamba, Hemchandra. Vishwananda Doctor Bra. Type and Doctor. Anyway, so today I'm going to start with linear algebra. The basic thing that I'm going to start with is with the vector space and its basic properties. So let's talk about vector space. What is a vector space? Vector space, people write it like this. Okay, this should be a field. Okay, and what else? Let me just write the properties, or is said to be a vector space. Is said to be a vector space. The notes I have given you, this is just a rough a recall. Vector space if number one, V plus is an abelian group. I hope everyone is familiar with this abelian group, right? Number two, alpha, for all alpha belongs to F, you call this as scalars, and V belong to V. Alpha times V, it belongs to V. Okay, then alpha V1 plus V2 equals to alpha V1 plus alpha V2. I don't need to write for all the time. Then there is this alpha plus beta V equals to alpha V plus beta V. Number five, alpha beta V equals to, I think it should be like this. Let me correct. Let me correct. So this is alpha beta V is equal to alpha beta V. Okay. Then number six, this is 1 times V equals to V. All right. This is the unity of F plus dot. Okay, this is a field. This is a field. I have written this down. Some examples of fields are, some of the examples of fields are this thing, R plus dot, okay, Q plus dot, complex numbers plus dot. All these are easy examples. Then your ZP, addition modulo P, multiplication modulo P, even Q root 2. I think this is also, okay, better not go here. I think this is a vector space. You will create confusion. Then what else? Then so many examples of fields. We'll be talking about this in case of modern algebra in rings as well as groups. All right, so these are some of the examples of fields. MNF is not a field. MNF with respect to usual, I mean, matrix multiplication as well as matrix addition. But I think this guy is a abelian group, no problem. Addition, with respect to addition, this is an abelian group. With respect to multiplication, it is not commutative. Okay, all those things are there. With respect to multiplication, it is not commutative, or yeah, not abelian. Commutative you talk about in case of rings. In case of group, you talk about abelian. Okay, so these are some of the basic recalls. All right, and I also wrote down that if you have any field over itself is always a vector space, always a vector space. All right, that means R over R is a vector space. Complex numbers over complex numbers is a vector space. ZP over ZP is a vector space. We don't usually talk about this. Okay, I don't know the reason, but F over F is always a vector space. Okay, so that is mentioned. Now we go move on to subspace. Subspace is like this. You have a subset. You have a subset of a V here. Subset of V here. I think it should be non-empty, and the W is said to be a subspace of V if it is a vector space in itself. With respect to what? With respect to the addition and multiplication. I'm sorry, addition and multiplication of V. Whatever your addition and multiplication V has, W should also have. All right. Then how about the subspace test? The important one is the subspace test. Subspace test. Okay, I'll just sum it up and write it like this. If and only if alpha x plus beta y belongs to W for all alpha beta belongs to your F and your X Y belongs to your W. Sometimes I do like this instead of this. This also works. Okay, so you can note this down. I think this sums up a lot. I mean, like sida tawgadaba step ama sida samjalleko. Aduna si nungaibini sise si happy ishan bayai ko. Kayino haiba kanda kogi see why am I saying this is because we will try to follow try to utilize the approach which involves the minimal steps. Why this? To save time. Because a lot of questions are going to be there, which is going to take a lot of time. Question ayamba mayam ama yarakani ko matam yam thina lowba question mayam yarakani madu sing duba koina matam pinabagidamagta araiba singda koina sigumba approach sing se ka minimal step involved oba kino sing si yaringai taunaba honasi ka. In fact, linear transformation ki matangda check toba kan sida suka. T of cx plus y equals to c times t of x plus t of y. Even in case of linear transformation, I wrote this step when you could have written here t times alpha x plus beta y is basically equals to alpha times t of x plus beta times t of y. This is basically more or less the same thing. So I'm going with this approach because it saves a lot of time. Yan tayo ko hijab. Aduna you can still go you can go ahead with this approach. Okay. So I wrote down a series of tests which you might have come across. Noina thengnaramba mayam yaramani madui potto loinamak khangani amamtang hangagadi ko adubu thuna recall tawba haibasi yam thina darkar ni aduna ni ko aina ithoi de ko subspace test and your subgroup test ko habe torapa recall to minisi ko a minus b if and only if a minus b belongs to your h, which is a subset of g, or this is with respect to addition. With respect to addition, then a b inverse belongs to h, which is a subset of g. All right. Then there's the subring test. Then there's the subring test. What does the subring test demand? A minus b belong to your subring g s atum hai ko. Then a into b belongs to s. Okay. The inverse will be in case of subfield test. The inverse will be in case of subfield test. If and only if a minus b belongs to s and then a b inverse belongs to s. Okay. Let us do one small example. Yeah, linear transformation LT test. I think I have written this down. Linear transformation test is like t times c of x plus y is basically c times t of x plus t of y. Okay, let us do some quick examples. I want you to prove this prove that Q plus dot is a subfield of R plus dot. So quickly, you apply this test, everyone. You apply this test. Does it satisfy or not? Just a quick warm up. I think that should not be difficult. Please apply this subfield test and see if this holds or not. Just do that, and in the meantime, can I come up with a better question? Can I come up with a better question? Okay, which one of the following is subspace subfield? Subspace with it Ponica. So if I try to do this, no, I shouldn't talk. I shouldn't talk. If I try to do this, you take here. How should I write this? How should I write this? R S belonging to Q. All right. Then basically we know that the difference of rational number is again a rational number, which we don't need to prove that the difference is ꯑꯩꯈꯣꯏ ꯑꯗꯨꯝ ꯈꯪ ꯂꯩꯔꯕ ꯄꯣꯠꯅꯤꯀꯣ ꯁꯤ ꯄ꯭ꯔꯨꯐ ꯇꯧ ꯍꯥꯏꯇꯥꯔꯗꯤ ꯐꯔꯛ ꯇꯥꯏꯀꯣ. I think we know this, and then the for all let's say s not equal to 0, s belonging to rational numbers 1 by s, it also belongs to this one. Proof तौरꯛꯄꯁꯦ ꯐꯔꯛ ꯇꯥꯏꯁꯦ. Am I just assuming that this is a field? Am I just assuming that this is a field? C 하여ꯒꯗꯤ ꯊꯕꯛꯁꯤ ꯂꯣꯏꯔꯕ ꯄꯣꯠꯅꯤꯀꯣ. ꯌꯥꯝꯅ ꯀꯩꯅꯣ ꯑꯣꯏꯃꯟꯕ꯭ꯔꯥ ꯑꯩꯁꯦ. C proof ꯇꯧ ꯍꯥꯏꯔꯒ ꯁꯤꯗ ꯑꯗꯨꯝ ꯂꯧꯁꯜꯂꯕ ꯖꯥꯠꯂꯥ. ꯀꯩꯁꯨꯕꯨꯗꯤ ꯀꯥꯏꯗꯕ ꯄꯣꯠꯅꯤꯀꯣ. R by S belongs to Q 하여가 ꯂꯥꯛꯀꯗꯣꯏ ꯄꯣꯠꯅꯤꯀꯣ. ꯌꯥꯔꯦ. Anyway, let's not waste time here. Let's not waste time. ꯌꯥꯝꯅ obvious ꯄꯨꯗꯤ ꯑꯣꯏꯅꯔꯕ ꯄꯣꯠꯅꯤ ꯑꯗꯨꯗ ꯑꯩꯅ proof ꯇꯧꯔꯕꯁꯤꯗꯀꯣ. See, there's a thing in research. Okay, when you ask to prove something, you should ꯍꯥꯏꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯃꯗꯨ proof ꯇꯧꯅꯕ ꯍꯣꯠꯅꯕꯗ lemma ꯁꯤꯖꯤꯟꯅꯕ ꯌꯥꯏꯕꯀꯣ. We can use other lemmas or we can use other proposition, but kitang kay ꯍꯥꯏꯇꯥꯔꯦꯅꯦ. ꯑꯩꯅꯁꯤꯗ kaya pallise. I'm thinking that I'm kind of using the definition of field here ko. Using the definition of field here, which I was supposed to prove ko. Aduna ni ko ina kitang confusion laise. Anyway, this is not important. Khangaba lairaba po ni ko. Adu sa puli sumaina hangge. Sumaina hangge kari hang sige. Complex number. Yes, kananong kanong hari.
is to 0 को मानद्रबनिना rational number ni p by q form the लादन अद p से q से simultaneous अनिमक को 0 ओइररोय अदु एरगदि अदु इंटीजर ओइग्राफिना numerator is 0 ओइररोय बा denominator अनिमक ओइररोय.
Okay. CD Masagi Hanadagi. So S is non-zero implies that P by Q is also non-zero. Nang hiding se that inverse exists adu never lang se. Adu Buddhist dedum yaw the yar of port never ko. Adu Buddhist dedum yaw the yar of port.
Sir,
Anyway, yeah. Ha.
Sir, course Q low was R Hanbagi subfill or yadi subset of R han and low. The
Okay.
S Q the element of tardy R the element R the already fill and assume to.
Okay, I see approach na khara yadori ka. This is going to be more safer ka. Luring mana hiding to sidum yai si chumi ba pot se. In fact, sida chatra su yad yai ba. Aina sida si chat pa pot se ngasai gi. Aina khalam mana Q se sa feel oire hai ba gi pot ka. Ado okay. Sigi pot sina pushlaga ka. Sigi pot sina pushlaga. Argument to hai tare ka. Step pudi chumba. Argument to ki wani ka. 1 by s is contained in set of real numbers, so therefore R itself is a field, so 1 by s exists. Hairega dom da puthoba shudi kai deka. aduga in fact adom da dum puthoga tawdi yamna di obvious oba pot ni ko sida tawri pot se it looks so obvious ka it looks so obvious yare pare si oini boy jersano we know that this is subfield let's not spend further time here yare ka now my question is you have a okay this is going to vector space my question is we can this is a field here some of the subfields are some ni ko haja mayam lem be ko in fact kaino the modern algebra da when you talk about this there is a formula ko if I'm not wrong the subfields is like number of I think it is like this if cardinality of your f is basically p to the power n number of subfields is basically equal to tau n, something like that. If I'm not wrong, in case of subfields, it is like this. But for such, this is a finite field. This is not a finite field. All right. No, sorry. This is not a field. My my field that should be. We should be very careful about this, guys. Okay. I'll tell you why I'm being careful here. See, basically, this is not an integral domain. If people know, it's good. If we don't know, it's still good. I'll be talking about this more in the modern ring theory class. This field in question is like this. This is p x to the power n, some, let's say, p of x. All right. This is an irreducible polynomial of degree n. Okay. It should be zpx, and I'm just writing p here, px, because this is an irreducible polynomial of degree n ko. Anong ganda ni ko si minus cannot go ko. So if you observe very critically, this is how it should be looking. All right, this is there. And then a finite field D, you can find a number of subfields, and this basically equals to tau and ko. Aduga sigumba infinite field D, I don't think there is a formula to find the number of subfields, but we know some of them. Some of the easy ones are like this. This is a subfield of complex numbers, and this also is a subfield of complex numbers. Yay ko siya. Sina masagi ko jere, sina sigo jere ko. Yay ko. These are some of the easy examples. I na see high se karigino high kana huzik. We will move on to this concept of koi subspace oiba oiba matang se ko. So you have here F1. I'm just writing this in bold. Why am I writing this? I'll tell you why. This is F prime. So these two needs to be fields. When you talk about vector space, you always talk about fields here. The inside, the one that is inside is going to be a field. F1 and F2 and F prime needs to be fields. Now, when do you say that F1 over the field F2 and F over the field F prime is a subspace of this? The condition is if number one, this is F2 is equals to F prime. F2 is equal to F prime, and number two, F2 is a subset of F2 is a subset of F2 is a subset of F1, which is basically also a subset of F. You look at here, F2 needs to be contained in this guy, and this guy needs to be contained in this guy. So this is what I'm basically saying. Aina sida F1 ga F kada magi bold haptrise moise feel oy so yam phare oidraga su kasu kai deba ko gyan tai ko haisa example p with the kitang mudi warani ko because aina mnf the p target d mnf the p target d no, this is going to be tough. Finding an example where these guys are not fields are going to be tough. It's going to take some time. Example. Let us go with the easier approach first. F1 and F na masagi field oida base kitang wana thok turi ko thiba kanda ko. Anyway, I'll think about it while you solve one question here. First of all, the example is I asked you a question in your notes. Is this what is that? Q over Q a subfield or a subspace? Forget subfield to subfield that subspace of R over R. Now the answer is no, because why? Because your this guy and this guy are not same. Yeah, see manabam daga type. You need to have a condition where magi manung dale field ani to manabam daga type. Yan tai how about this guy? Is Q over Q a subspace of R over Q? And you can say yes. Well, number one, why? Because the ones which are inside are same, fields are same, fields are same. Number two, because this guy is contained in this guy. The field is contained, the field that is the inside is contained in this, and then this, the superset of this field is contained in this guy. This is what I was referring to in this F1, F2 gi matang sida ko. Aduna C oiba ma mathok tai manung gi field manabam daga tai manung gi field manare hire kanda sina C de contain togadamne, and this guy is going to be contained in this guy. Aduna C ma maintain togadamni. Sida mapan gi pot singsi loi mak masamak feel loi ojai ko adu oi da pot di kitang wan na thoi ko to khan ba ko ai khan ba yabram ti yenge. But anyway, maduma legre kan hojik there is one some of the easy basics matang dan some of the important propositions. Now this proposition we will not be proving this proposition. We will be using the results and we will be understanding them. Okay, we will be understanding the propositions, the important propositions on subspaces. I have compiled the important, only the important ones. All right, the ones which I don't feel important, have not included them. Aduga, if you feel while going through the booklet or coming across some other test series or nang test the question tharapakanda, if you feel some of the propositions you came across or results are important, then you are free to add them in this list. I'll just sum this up. It says that any intersection, whether it is a finite intersection or infinite intersection, or you can even say an uncountable intersection of subspaces of V is still a subspace of V. So question macam sa hangi ko. Subspace. Adu puto patam ko hang ba yaro editi. Ay na hangi to is uncountable subspace like ba. Ako ko kano sida. Let me just see if I'm right or wrong. When you defined V as a function from R to R, okay, when you define V as a function from R to R, I don't know whether this was continuous or not. Let me just confirm. I did come across one example here. Continuous ya or suya bro, bro. Okay, so this is just a function. Is a function. All right, and you defined your. This is what I'm trying to say is mana field kana today. If this is a vector space, what is going to be your field over R? Over R. So V over R is a vector space. V over R is a vector space. Let us assume this is true for the moment. Okay, I did not write this here, but my example is, I'll tell you why I'm writing this. You define a function like this, f from R to R, such that f of x equals to e to the power m of x. Okay, so why am I writing this is basically an uncountable Okay. My question is different. God, this is basically an uncountable set actually. Aina pami there are uncountable number of subspaces having ko. Kenai ko. Okay, maduna kenai ko. This is an uncountable set. Okay, this is also an uncountable set. Chida dimagi basis ki matang dalak continuous and bounded vector space. Tuti CD kinoto winiko. This is just to prove that V over R is basically V over R is basically uncountable. So this example is not working. I was interested in other examples. I was interested in this number of subspaces are finite, infinite, and uncountable. I don't know whether I'll be able to give all these examples, but some of them I think I can. So this is a different example. Let me rub this. Uh, let me rub this. This is a different example. Finite key D. If I go with the set of dimension, the dimension like the subspace. So you'll be coming across this formula. I think maybe tomorrow. P to the power n on n minus 1 by 2, p minus 1, p minus 2, so until is it p minus 1? I'll just write this p to the power. Okay, it is p square minus 1. Such things, they are very confusing. Okay, so you need to revise these things over and over again. So it is like this. So p to the power n minus 1. Okay, p to the power n minus 1. What is this formula that I'm talking about? It talks about the number of this is for the number of, I think, linearly ordered basis, I guess ka I irake ka ordered basis. Yes, yeah, this is this. And if you talk about the number of subspaces of dimension k, subspaces of dimension k which is strictly less than n, it is basically like this. P to the power, same thing, n on n minus 1 by 2, so until p square minus 1, so until p to the power n minus 1, and you divide everything by the k version ko. K version do not divide to p minus 1, p square minus 1, and this guy will be replaced by k minus 1. Okay, this is for the finite dimensional vector space of dimension n. This formula is for a finite dimensional vector space. Question I will be talking about this in detail tomorrow. See that finite dimension infinite ki matang da, I think one example just came to my mind at the moment. You have this here. What is this? The set of polynomials. It's not the polynomial. It's like this polynomial height at the degree lakani ko. Here there is no strict degree. It is like this. A to x square, and you go on. It does not end. All right. Why? What is the difference basically between this and this? Please observe the difference. A naught plus a1x plus a2x square, and it ends somewhere. Okay, I don't know whether writing polynomial is nice or not. Polynomial either so but anyway, let's say fx. Let's say this is fx. All right. Now for such vector space, the basis, we'll be talking about basis tomorrow. The basis is, in fact, a quick reminder. The basis is what is this? Linearly independent. Yeah, the first one is it is linearly independent. The S is a basis. S is a basis of vector space. The first one is it is linearly independent, and second one is it S linear span of S is basically equal to V. That means S spans V. I think we know this, right? Other shigi magi basis sekana oyi kanda, you define your S to be 1x x square, so on. It never ends. So therefore, dimension of Rx, this is basically over R. All right, this is basically infinite. And dimension of dimension of R n x, all right, over R is basically your n plus 1. I think this should be n plus 1 ka. Why? Because 1x so until x to the power n is going to be our basis. So then is about the n like this, amaduga n plus 1. Yeah, because some people write this like this, all the polynomials of with coefficients over R and degree less than equal to n. Yeah, because okay, simple lingay ito kinomta hayo ko. Why he writing degree less than equal to n? So please listen to me carefully. So suppose you define a set S x here, or let's say okay here. Hi. Suppose you define your skx here as you p of x equals to, let's say, a naught plus a1 x plus so on till ak xk. All right, such, or you can say the degree of p of x is exactly equals to okay. Okay, let me do some of the cases. Number one, k equals to 0. Okay, when the degree is equal to 0, you're basically talking about like this. Let's say a naught, and your a naught belongs to R, right? This is like ai belongs to R. You are basically talking about the constant polynomials. Here you can say that this guy is basically 0 belongs to this, and this is basically if you do about isomorphism, or it is basically similar to a subset S of R. Any subset haibadi yaroiko sidadiko. You have to be very particular. You have to be very particular. Sigi S in karigumba koigi, if it was Q gumba oitargadi, Q gumba oita atai diabro. Let us try to prove this. Okay, let us try to prove our subspace test. Subspace test to palaga yung siko. When you try to prove the subspace test, in case of k equals to 0, basically you can say that this 0 belongs to S not X, which is fine. Okay, simple just observation yun ko sir. Because in many questions you have to look at whether this 0 belongs to yours, the subset that you are going to test for subspace ko don 0 si yeng daba yaroi ko dong ganda ko don 0 yeng bire phare ka shukai de sinadi guarantee to ba ko mana pam se alpha times x plus beta times y habi poto ni ko, it belongs to your s not x habi poto lakad ni ko. So sidadi, can I come to a contradiction here? Can I come to a contradiction here? Should I think for an example, or should I go for the proof? Let me go for the proof ko. Let me see. Alpha belongs to alpha, beta, moi say real number de yao ba, and your x and y belongs to your s naught x, which is basically your constant function. All those constant functions, right? A naught belonging to set of real numbers. Okay. Will this create any further problems? So alpha times x plus beta times y. This is basically, what is this x? X is so it's mine eg ko. I'm trying to prove that this is a subspace subspace. So if I write it like this, okay, so x will be equal to some, let's say, b naught, y will be equal to some, say, c naught, and then alpha times b naught plus beta times c naught. I think this will also be again a constant. Yes, because it's a collection of all those all subsets. Okay. Sida ay nahining is ko, no ubre yung ko. When I talk about S naught x is basically the set of all say basically the set of all constant functions. You can clearly see that R is the set of real numbers is contained in S naught x. Can you see? Yes or no? Miss Onika Lakshmi, can you see? See Uber ngambrio. Aina the set of all constant function high bakan the real number set of real numbers yawi hai sinu Uber ngambro ngam the bro. Onika Lakshmi, can you see this? When I have written this down, we ude.
Ude.
Ude. Okay. Okay. Bubu Sri Ubro. Bubu Sri Ubro. Can you see what I'm trying to say here? Kana kana uyi ude ki yengi ko. Bubu Surjit Ubro sita. I'm trying to say the set of real numbers is contained in S naught X. What is S naught X? X naught is the set of all constant functions.
Sir, we sir.
We got. Onika sumai si ko. Si f of x say S naught X the yaw ko. Look carefully here. I am taking a particular f of x which belongs to S naught X. And f of x की value say magi see it's some going to be some a naught ka, where a naught belongs to real numbers, right? See a naught say particular fixed deco. A naught can be anything ka. A naught can be anything. So it can be 0, it can be 1, it can be to any real number that you take. It can take the value, can take can be any real number. I think the word should be can be any real number. Can be any. I'm sorry. Can be any real number. If we are not happy with this, a constant function we know that let us forget about this for the moment and let us visit this thing. What are the constant functions? Constant functions are what? You have fx equals to some k, and let us talk about a set of real numbers. So k belongs to real number. Okay, so k can be 1, k can be 2, any real number that you take 0, then minus half, it can be anything. Have the set of value of fx such that f of x is constant. Hi bakans the mangon is the magi even mana babu ko magi cardinality sika. We know about the cardinality, but mana babu lakatori bakinomter. But anyway, madu makhang mangamdragasu. You know that this is contained in this because fx can take any value of r. R की जितना लगी वैल्यू दो लोने मग लो भी आई को उनका ऐसी यानी ब्रसी की स्टेटमेंट से R से ngak to kro ko can take any value of R से यानी ब्रा उनका sibok di constant higher banina sibok di यानी ब्रा
Hoi da.
यानी ko si ya taragati R की जितना value लो भी यार banina R masamang से तुम याव द्रो मने सिदा ज्ञान ताई को से fx से 1 2 3 जितना लो भी यार लो याव यार अदुना even if C poche even sibok को मानरा कोई film lakani bako madu chatraga su kaishu kaiti R से contain tawni haba या को से so Miss Flora, are you able to understand what I'm trying to say? I'm basically saying that a set of real numbers is basically contained in this set of S that I'm defining. What is S? S is basically the set of all function where f of x is a constant function. And what are the values that it can take? It can take any value of R, any value of real number. So I'm basically saying that set of real numbers is contained in set of S. So do you agree with me or
Yes,
not on this?
yes,
Okay.
yes, yes.
Okay. Okay. Chalo. So that is being settled. Now coming back to this, I want to show that S naught X is a subspace. Okay, so coming back, you have alpha and you have beta, which belongs to set of real numbers. Why? Because I'm basically talking about R of X over a set of real numbers here. And I'm just taking a set like this over this. Okay, I want to prove that this is a subspace. I want to prove that this is a subspace. And so therefore this has to be from the field. Field kanano C Nicola Isika. This has to be from the field and your X is equal to B naught and your Y equals to C naught. They belong to your belongs to R. See, actually this is, I think I should write it like this. So to avoid a confusion go. S naught X. Yeah, because I high do magi kino the yaw them have ko magi W da aduniko C W do Nicola Now, what happens is when you take about alpha times x plus beta times y, which is basically alpha times b naught plus beta times c naught, they belong to set of real numbers. Yes or no? They belong to set of real numbers. Onika Lakshmi Siyaningbra, they belong to set of real numbers. Kasi kahit ikaw, all these are basically set of real numbers. Yay ko siya. Sisu real number ni, sisu real number ni, sisu real number ni, sisu real number ni. Ito tadi mo linear combinations real number da. Yaw ko ni hiyaning ikaw. Monica Lakshmi. Since alpha, beta, and your B naught, C naught belongs to real numbers, the linear combination alpha times B naught plus beta times C naught, they belong to set of real numbers. Sino mo koy uzay da? Real number di ako'y field masama o jere dudi. Natro? Field oire, dagi even field na natana magi field oide ni ko, field oide lag sabring su oire ko, sabring gi mayam to oibna maram oire ka, si se real number da yaw reba. Aduga CD sida yaw reba. Once you have proved this, therefore it implies that S naught X over R is a subspace of Rx over R. In fact, this is some people may try to say this is similar to or isomorphic to Haigadraka. Isomorphic to saying R over R. Because why? Because the my constant function ngata kak oibinina sumaina lakani ba. Now, sida problem mo thokani buko. This is when your k was equals to 0. When you try to fix k to be any non-zero, let us say k equals to 1. Let us say k equals to 1 and you are looking at s1 of x. What is s1 of x? S1 of x is collection of all those functions belonging to r of x such that you can basically are basically saying degree of f of x is basically 1. S1 of x is collection of all those functions from R of x such that degree of fx is basically 1. 0 yaw sida. Miss Onika Lakshmi sida 0 yaw gudro. Ako Onika Lakshmi yaman ko. Saurani. Kananam lang ko. Renubla. Renubla si igan mani. But anyway, irasu kumo 0 yaw gudro. Yaw ni natraga yaw roy. Does 0 belong to this set S1x? Yes or no? Tunam kumo. Chat box te irakera chinang kumakera. Miss Renubala. 0 belongs to S1 of x. Is it true or is it false? Is it yes? Why? 0 की degree से क्या लग गया? Lurengamba, 0 याव को draw. Does 0 belong to this set? Renubala says 0 belongs to this S1x. Do you agree with me? Do you agree with hers, basically?
On the degree 1
Degree 1 higher Banina?
0 yaw degree 0
Yes, the degree of 0, the constant function 0 is basically 0. Renubala gyantai ko si Sam. See, I'm writing here, it is basically exactly equal to 1. If it was like this, then the degrees can be 0, the degrees can be 1. All right, this would have formed a vector space. All right, but here I'm saying that the degree of f of x is exactly equal to 1. It cannot be lesser than this, it cannot be more than this. So it has the collection, it has, in fact, the basis or the function will look like this: fx equals to x or fx equals to 1 plus x. All this monic polynomials sorry, not monic, monic fx equals to 1 plus twice x, all this collection of this where the degree is basically 1 here, 1 here, 1 here. It is basically the collection of all those polynomial functions. If you don't want to say polynomial, you can say the functions of degree 1. Okay. Yeah, so it does not contain the 0 here. 0 does not belong to the collection of this because it has degree as 0. The degree is 0. Can take the degree is 0. So 0 does not belong to this. And once 0 is not belonging to this, when 0 is does not belong to this, it is not a group. The S1x is not a group. With respect to addition, is not a group. Forget about abelian group. It is not a group, because for group you need to have the identity, the zero identity. The additive identity. Understood? Flora, are you able to understand my argument
Yes,
here?
sir.
Zero. Okay. So aduna renewable section view. Please be careful. Ko sida ngasagi zero se yauroi kai maram gna haiba kanta mana degree se exactly 1 taba pame haiba ko. Exactly 1 pame, but zero is has degree zero. Ko aduna sida yauroi. Even any constant function, uh, any constant function, or let us say a polynomial, has a degree equals to zero. Yan ko haja. And aduga degree 1 hierarchy tadi kanadi ho gaya hai kanda, when degree is basically equal to 1, your px takes the form of x ka. X times some scalar, or mine either CR x, 1 plus x, all those things, 1 plus twice x, all those things are degree basically 1. You have degree 1 here, degree 1 here. Yeah, so the argument is uh, r and x. Let's come back to our example here. F of x such that degree of f of x is less than equals to 2. This guy is a vector space. Okay, but your Sn x, f of x, such that degree of f of x is exactly equals to n, and not equals to 0, is not a vector space. Is not a vector space, is not a subspace. However, I think this guy, which is basically equals to your constant function, degree of f of x is basically equals to 0. I think this is a vector space. This we have proved this. In fact, this is basically saying the same thing as this one. So this is one observation I would like you guys to keep in your mind. And almost similar to this is that your infinite this thing here, f of x equals to a naught plus a1x, so until it can be anywhere. It can be anywhere such that your ai's belong to set of real numbers. And here, let's talk about the dimension. Let's talk about the dimension. Dimension of r of x is basically infinite here. And in this guy, dimension of Rn of x is basically your n. Why? Because your basis set is given by 1x square, sorry, 1x square, so until x to the power n. From here to here is n, and then you add 1, so it has n plus 1 elements. I'm sorry, this is n plus 1. N plus 1 elements. And for here, the basis set is given to you by 1x, same thing, but it does not end. All right. So this is cardinality is infinite, so this is infinite. Okay. So this is an example of an infinite dimensional vector space. Okay. This is an example of an infinite dimensional vector space. Infinite dimensional vector space. And this is an example of a finite dimensional vector space. Finite dimension. Okay. Finite dimensional vector space. And thank you, sir. We'll be talking a lot about Rnx and Rx. Okay. In fact, let me walk you through one of the propositions, which is at the end of your today's notes, Lorem Daida. When you are given V is a vector space, see Rn Rn Rx and you have a W which is a subspace of V, a subspace of V. The question is, the question is like this: V slash W. What is the general notation of this? The general notation is VW, where V belongs to your vector space. I think we have come across this cosets in case of group theory. I think the word is coset, right? So X plus H, all those kind of things now. So it's more like that. It's more like that, cosets. If I'm not wrong, the word should be coset, right? So it's G by H, or quotient space. Quotient space. I think the word should be quotient space. So the notation of V by W is of this form. And if you want to talk about dimension of such spaces, if V is, I have written this down in three cases. If V is a finite dimensional vector space, then this is dimension of V minus dimension of W. Um, observe carefully the difference between this V by W. I think I should write it like this. Generalize the thing, huh? I think I should write it like this. If W is finite dimensional vector space and this is infinite, if V is an infinite, okay, I need to be careful here. Infinite dimensional vector space. However, there also comes to be, it can be a finite. Should generalize the way I cannot generalize this. I cannot generalize this like this. Just give me a moment. I think I should write it like this. In case of infinite dimensional, there is two cases. One of them being finite and infinite both. Okay, yeah, I think this should work. Let me give you example of both. Let me give you an example for both. Some of the examples for V by W is like this. Rx let me take an example. We know that this guy is of infinite dimension. Okay, let me give you an example here. Let us go with the finite dimensional case here. You defined your, if you say you take your S x over Sx to be what? Sx to be, it defines like this: P of x belongs to R. Try to understand what this example states. P of 0 is equals to P dash of 0 is basically 0. Let us try to break down this example, what he is trying to say. Mana haining isi kaino da khangminasi ko. Mana haining isi kaino si khangminasi. Mana hai si kaino hai ka anda. Basically, he is saying that it is of this form. Since it belongs to Rx, it is going to of this form, a square x square, so on. It does not end. But however, he wants us to satisfy these two cases. That means P0 is basically equal to 0, which means that A0 plus A1 0 plus A2 0 square and so on is basically equal to 0. All these are 0. No problem. Moilamak 0 sa he wants A0 to be equal to 0. Okay. I hope you are able to understand this. Then he also wants P derivative of the at the point 0 is basically 0. That means when we take about the derivative, it is basically um, A1 plus 2 times A2 x, then 3 times A3 x square. This is basically your P derivative at the point x. Natra? P derivative at the point x niko sisa. Aduna sisa lani 2 times of A2 at the point 0, 3 times of A3 at the point 0 square. All these things are 0. So he's basically saying A1 is basically 0. So this our given s of x is just saying that, sorry, this is s of x is just saying that your px belongs to set of real numbers, real number x, such that your a0 equals to a1 is equal to 0. So that means it looks like this: a2 x square plus a3 x cube plus so on. Can everyone agree to this statement? Your AIs belongs to set of real numbers. Okay. See you, bro. Hemchandra, see you, I have solved that when you put these two condition, ako'y na P0 ga P dash 0 ga 0 equate to bakanda, ako'y A0 equals to 0 tare, A1 equal to 0 tare, aduga SX hybrid karino, sumay ni itok pa na hena nungay ni ako'y dako. CD hybrid karino, A2x square, A cube, x cube, sumay ni itoy si yaning de bra, Mr. Hemchandra. Yaning de. Yani aning de.
Yang.
Yani ka. So so this is fine. Now let us decode even further to make things much more easier. X square a2 plus a3 x plus a4 x square so on. AI belongs to the real numbers. Here even I'm just simplifying. I'm just taking out x square common, right? Px equals to x square. Can I write it like this? Same thing, huh? No problem. I just took out x square common, and when I took out x square common, it is coming out like this. The inside part is basically an element of r of x, right? Till here it's fine. So when I write things like this, so the lowest power, the lowest degree is basically x square. I hope everyone can clearly see. Uh, for any, let's say, p of x belonging to s of x, degree of your p of x, it has to start from 2. It has to start from 2. Yan tay ko hay siya? Yan tabra? It has to start from 2. It has to start from 2. Do I need to write further? Do I need to write further? 0, 0, 0, 0, 0. No. Yes, it has to start from 2. Why? Because we have found that the a0 thing and the a1 thing has to be 0, so it has to start from 2. Yan tayo sir. For any, I think this observation, everyone is happy with this observation. All right. So therefore, a basis. I'm saying a basis because there can be many bases. A basis for s of x is the set. Let us say t here. It looks like this: x square, x cube, x4. Because degree of this, it has to start from 2, so this it begins from here. uh, if we talk about that, we come back at this. Why is this infinite? It starts like this: 1x square, sorry, 1x square, x cube, and so on, right? This is infinite. Okay, and for this guy it has to start from 2, so it starts from 2 here, 2, 3, 4, and so on. This is also infinite. Can you see this? Dimension of s of x is basically infinite. Now dimension of your r of x slash s of x is basically what? This is dimension of r of x minus dimension of s of x. Now be careful. If you go like this, it will be like this. Okay, so do not go like this. So this is wrong. You look at the you observe the set. You look at the set here. In case of dimension of r of x, you have seen that this set S1 x square. I think I should like it like this: cardinality of the set 1 x square. I think this works. Cardinality of the set x square, x cube, and so on. Right. So you differentiate the cardinality 1x. I'm sorry, this is like this. How should I say? I think it's better to not say you differentiate the cardinality. In case of such cases, I think it's better you try to find the difference in the set. Yan tayo kasi haiba set sida si pulap si sumay yaure si plus sumay yaure. Si gai khatok ki bahai tagadi. You are basically removing from here, right? So the things that are remaining is this two. So this is basically two. Okay, do not go with this approach of infinity minus infinity. Okay, this is wrong approach. So you go like this. I'm basically removing this part here from here. So the thing that remains is 1 and x here, and this is basically 2. So this is an example where this is an example. Just have a look here. Anyone who wishes to disagree to this are free to ask for different explanation. I hope you can clearly understand this. Gyan tagani ni khali ko ay wakal ko. Tai ta di amtang kumbiro amta. Kana kana yaw igi amtang yenge. Innocent si gyan ta bro. Ay na haining ise. Aina hiding is a cardinality the infinity minus infinity to chatpi ganu magi set tagi magi basis set to dagi akon dagi basis set ki yaw elements sing je khatok piral lemhori po to chatpi on haibini ko sida yaning the bro comment oge Mr. Innocent. Innocent su ai ba kangura ma Innocent yaw tab zala yaning sir okay yaning ko lo yaning am do mali ko ina khamba ko si gi technique se follow to view ko when you talk about infinite cardinality or infinite dimensional vector spaces, do not go for infinity minus infinity approach. You find a basis. You find a basis for that particular vector space. You find a basis for that particular subspace, and you remove you remove the elements, the basis elements of the second vector space, basically your subspace, and you find out the difference. Yeah, because so this is an example of where this V and W, they are both infinite dimensional, but dimension of V by W is a finite dimensional. Okay. Now let us understand an example where these two are infinite dimensional and this is also infinite dimensional. The same example, Rx I am taking. You take V equals to Rx. We know that dimension of Rx is basically infinite. Okay. Why? Because the set is the basis, x square and so on is the basis. You take, in this case, I will take Tx here, or T here is going to be equals to W is going to be equals to your W is basically equals to T of X here. T of X is defined as P of X belongs to set of real number, set of this polynomial function, such that P of X equals to P of minus X. Now there is a particular reason why I changed this into this. I first wrote, if you have seen carefully, notes the yang matamda aina hani iramise degree of P of X equals to twice hen haina iramiko. Shida aina bakali se kaino haikana aina si ibakan shida I am worried if you will misunderstand this for understand this for ngasai ko the degree of P of X equals to k non-zero gi case to ko madu chatkadra habigi pakhat mani ko aina tawisi ko adu tadi kitang pharak tai ko aduna madu gi confusion to lokthok napa. I think this should be safer side. So this is the reason I'm writing like this. Otherwise, you will have confused yourself with the fact that degree of P of X equal to K, where K is non-zero. And in this case, we learned that this is not a vector space. Okay. So to avoid that confusion, I just changed it to this. All right. So this is not the case. Okay. Now coming back to this, in hiding have a sit up. So when you write like this, you know that this is an even function, right? I'm talking about an even function. Ako even function gi matang ni ko wari size se. Adu even function karaba even function no even function mayam like ko. All these are even functions. All these are even functions. These guys are all even functions. But I'm particularly talking about the this thing, the even functions belonging to R of X. Basically the polynomial form ko. Why is a polynomial form with high, but this is not a polynomial because polynomial, when you talk about polynomial, we talk about particular degree. So we are basically talking about the even function of the polynomial form. All right. So if this is an even function here, the generating set S is going to be generated by 1, x square, x4, and so on. Shida no odd powers. no odd powers of x are included here. This is basically x equals to 0. All right. All these are even. Okay. So I hope noi yaningam gani ko aina hainingi pot sida. Aina even function haiba kansida. Even function karam even function rx they are even function high target. They are going to be generated by this set. Yeah, because is that they are going to be generated by this set and there is no odd powers of x included here. Okay. So an example of such of a p of x is going to be, let us say this is 1 plus x square plus x4. All these are even functions. So another examples will be qx is basically equals to your x square plus x6 plus x. All these, they are examples of even function which belongs to this. All right. And what are the generating set? What is the generating set? The generating set is 1 x square x4. Okay. So this dimension of t of x is basically infinite because this has infinite number of terms. Okay, this is infinite. And when you try to find out the difference of the quotient dimension of the quotient space, let's say v by w, this is dimension of v minus dimension of w. But like I said, if it is infinite dimensional, do not go with infinity minus infinity approach. You go like this: cardinality of 1 x x square and so on minus cardinality of 1 x square x4 and so on. This is cardinality. Aduganda, this is you're talking about the cardinality of this guy. So 1 year, right? X cube, x5, x7, and so on. This is again infinite. Okay? Si yaning da bro. Amtang muna yung ahamada ina dimension v puthokre akhoi loi khange si tare ko. Dimension w di kana taba. It is generated by the even powers. The even powers no x power 0, x square, x4, all these things. When you remove these guys from here, you are left with only the odd powers, and this, in fact, is still infinite. So this is infinite dimensional. And I hope you agree to what I'm talking about here. Si gyan tagi tari thawak akhoi gi makha taba rx ki matang da rnx ki matang da phanam gyan tarani ko atai loi laira ni. So this makes things easy for us. I hope everyone is happy with the explanation I'm giving here. Okay. Yes, these are some interesting examples. It's a good thing that I know hana hayo record. Okay, so everyone is happy with this, I guess. Anyone who is not happy? Onika Lakshmi yai ko sise tori sing sep. I want to go ahead. Yai.
Dạ đó.
Okay. Chalo. Makata na toksiko. Coming back to our properties, I don't know till property number kya bo kai ngang kai khang ko. Sorak pa slide sum chakre. Okay, constant. All right. Subspace. Okay. See subspace masing tiba sa mahaying toksiko. Yeah. We have not talked about the properties of subspaces. So coming back to the properties, let me I think Siddharthi Akoina, let me just walk you by just explanation from my notes itself. That will be much better. That will be much better. Okay, so this is subgroup test. All these things we have done. Okay, chalo. So I have talked about any intersection. Finite, infinite, or uncountable of subspace of a vector space V is basically a subspace. These things sumo si slate exam gi maru ibani ko siguma sing se ko macha sing se yam hangan mani. Application based hangmanika. For people who are giving SLED exam, these things are important because they ask small questions on this application. What are the application? Let us walk you through it. If W1 and W2 are subspaces of V, then W1 union W2 is a subspace of V if and only if W1, either of them, one is contained in the other. Okay, so union is subspace if and only if one is contained in the other. Okay, this is not difficult. Second thing is W1 plus W2 is a subspace of V that contains both W1 and W2. Okay, so if you don't know how to write this W1 plus W2, if you are not familiar with this, oh my God. Just give me one moment. I don't know what seems to be the problem. Okay. Okay. So W1 plus W2 is what? It consists of all those elements W1 plus W2 such that the W1 comes from W1 and W2 comes from W2. Okay. This is the notation for W1 plus W2. All right. Now coming back to the property. So W1 plus W2 is a small, no. For W1 plus W2 is a subspace of V that contains both W1 and W2 ka. W1 is contained in W1 plus. How is this possible? This is possible because you can write it like this. For all W1 belonging to this W1, you can write like this: W1 equals to W1 plus 0, which basically is contained in W2. 0 yaw equals to the. I hope everyone can see that 0 belongs to W2. So therefore implies that W1 is a subspace. I'm sorry, subset of W2. Similarly, W2 is also a subset of W1 plus W2. Okay, these are easy things. And when you have found out that W1 and W2 is a subspace, mo ise contain taweba W1 to W2. So tadi magi say it is the smallest subspace containing both W1 and W2 ka. Hiding is kaino sige notation sige tabram thing mu ka. For all W, which please make one change here. You make this as like this. I made a mistake here. It should be like this. For all W, which is a subspace of V, such that W1 is contained in W and W2 is contained in W, then W1 plus W2 is also contained in your W. It should be W, not V, okay? Amtang chungthokpiyo ka. Si se aina sida V hana I se W oigadabni ko si se. Amtang chungthokpiyo. For people I forgot to say this. I made a mistake here. This should be W. What I'm basically trying to say is subspace ama laireba ko. W hyper subspace ama laire. Aduga subspace hyper W sina W1 se yawi amasung W2 se yawi ba contain toiba ko. Adda aina haini argument sida mana this is the smallest subspace containing both W1 and W2. Yan tayo ko haini isa. Masagi si koi greatest lower bound adagi infimum ko adom da supremum infimum adugi sense lakadoi ni ko adugi sense ai tar si gyan taram gani na khali ko kasu lu da mani si ko si chunthok piro. Okay, aduga sida this is important. You have two subspaces W1 and W2. So the linear combination of all those subspaces, alpha times W1 plus minus beta times W2, all these are subspaces of V. Now there's the difference of W1 minus W2 ki type. That this is different from this. It is different. I hope you know I hope you clearly understand the difference between this. This is basically what? This is basically when you talk about problem na issue. In a Venn diagram, you draw things like this. This is V, this is W. So what is V minus W? Or you are basically talking about V union W complement, all those kind of things now. So Adunika, so V minus W is what? V minus W looks like, so it looks like this. Okay, so this is what it looks like. Okay, this is different. This is different. Okay, this is just like this. I'll say V minus W, where V belongs to V and W belongs to W. See the line union natra intersection oidura. I'm sorry, this should be intersection. Intersection oidini cosisa. This should be intersection. Okay. So I hope people are familiar with this. This is not a problem. Now, one interesting thing is this one. si yengbiu ko aina iri ba potse angang man isi kari haining no haiba kanda moi nan ningsang badan nungai namni ko w1 plus w2 intersection w3 is the superset of this here. That means it is not equal ko. This is the example, we'll discuss about this. I wrote with a red color here to help you memorize the thing with much more in a much more easier manner. I'm basically writing here, it says that you have more intersections, that means it is contained in, right? You please be careful about the word that I'm using here. Intersection yam taragadi contained tawgani haiba ko. Aduga somdana addition yam taragadi contain tawni haiba wahise ko. So I hope people are not confused here. I am just writing this because we tend to make a mistake. We tend to make mistakes. So this is a simpler way here. I'm just saying that if there's more intersections, that means it is going to be contained in. Going to be contained in, right? And I'm just saying here, if it is more addition, then it says that it is going to be contained. It contains, right? Let us talk about this example. Let's talk about this example. I'll just demonstrate you how this basically works. This is a very interesting example. So we are dealing with w1 plus w2 intersection w3, w1 intersection w3 plus w1 w2 intersection w3. So this is more intersection, means this is contained in. All right, let us take this example. You take w1 to be I took here c0, where c belongs to a set of real numbers. Number two, I took here to be equals to 0b. Your b belongs to a set of real numbers. And you take w3 to be equals to a belongs to a set of real numbers. Eko siya. Kanan pa hangi to be alert ko. Lure ngamba si se x axis oi habisi yaning bro, yaning da bro. Mr. Lure ngamba.
Yes, sir.
Si kana oi ba today, Mr. Innocent, si kana oi ge. Sin x axis oi kitari si kana oi ge. W2. What is W2? And what is W3? W3 is for W3 is for Tarun. Tarun si kaino. W3 sina kaino ne. Yeah. Sina Tarun gi. Sina kaino gi. Kanano ay lune ngamba hangre ko. Si kanada hangim no. Number 2 si kanada hangim no. Ay kaore. Innocent da hangim ko. Innocent si kaino. What is number 2 here? Lune ngamba ga aiga yana kre. This is x-axis. The W1 is indeed x-axis. So Innocent, please tell me what is W2. And please, Tarun, please tell me what is W3. Quickly. Tarun naman haro.
The straight line or
Straight line.
through
Origin, this is y equal to x, right? This is y equal to x. Okay. So this is y equals to x. Mr. Innocent. Khra lub sa hai gre Tarun na. Nang khra live sa haro. Innocent kayo do mali si 0b si kayo no. Innocent. I bidramas i bikangura. Idrine. Innocent mangrabo. Innocent lady ko. Innocent kayo do na si se. Hera. This is just simple question. Cartesian product Cartesian product hai kadra. Flora, what do you think W2 is?
Y-axis, sir.
Y-axis, okay. Very easy, right? Innocent si Y-axis oy diversible. Oy binikosi sa yung ko. This is Y-axis ko. Habidi kay no magi x si par ko di magloy na 0 tani ko. Aduga sida lay bakangko si oy duni ko. Everything that is lying here. Ay ko si sa. Oy dabar na 0 1 0 2 ma'am e ko sa. So aduna sigumadi kumbam thoy ko Innocent ko. Anyway, so we are going to demonstrate that whether this is indeed true or false. Okay, so first of all, what is this W1 plus W2? W1 plus W2 is basically what? It is basically you are adding C0 plus 0B. Okay, where C and B, they belong to set of real numbers. All right. This is basically your, I should say that it will take the form of xy, where x and y belongs to set of real numbers. This is basically R2. Because is that? Uh, if you want much more clarity, I will explain you like this. You know that this set C0 plus 0b is basically a subset of R2. Okay, this is done. This is pretty obvious. I want to express uh, this guy in the form of this. So xy is basically equals to x0 plus 0y. Right. So this guy basically belongs to your set here. Let's say W1 plus W2. So it belongs to W1 plus W2. Okay. So this implies that your R2 is contained in W1 plus W2. And as the result, therefore, you have W1 plus W2 is basically your R2. Okay. So this is the easy proof. All right. It is not difficult. Okay. Next we find W1 union W3. Sorry, intersection W3. W1 intersection W3. It is basically what? It is basically C0, the set intersection with this. Too many overwriting. Too many overwriting. So C belongs to set of real numbers. You intersect with 0 comma B. B belongs to set of real numbers. C intersection tauba kanda kay fangada 0 phangdoi ni ko si ka. 0 phangdoi. That means C logic something khangmina si ka. Intersect over means you are basically equating these two terms. All right. And from here you are getting C equals to 0 is equal to B. So therefore this is basically your singleton set 0 0. Okay, so this is W1 intersection W2. I am also going to find W2 intersection W3. I assume yes, W2 intersection W3. Intersection W3. This is basically C0. C belongs to real numbers. You intersect with your W3 is what? Your A comma A. A belongs to set of real numbers. Okay. How do you find this? You equate the thing. Intersection haidi managadam ni ka. The equate tawba kanda kya lake? You have C equals to A and A equals to 0. So therefore both these things equal to 0. So you have 0 comma 0. Okay. So this is not difficult. All right. So basically what he's trying to say is from our example, we can clearly see that W1 plus W2 intersection W3 is basically what? This guy is basically R2. You intersect R2 with W3 is basically W3. Okay. And then you have W1 intersection W3 plus W2 intersection with W3. This is basically what? We have found out separately that in each of the cases, it is singletons at 0, 0. So you are basically adding 0, comma 0 plus 0, comma 0. This is in fact 0, comma 0. Okay, and you can clearly see that this is indeed contained in W3. W3 is what? Your W1 plus W2 intersection W3. Okay, so this is the example to show that this is contained. Okay, to show that this is contained. Likewise, you can take the similar example and prove it for the second part. Second part. What is the second part here? The second part is W1. W1. What was that? Addition W2 intersection W3. No. This is the same thing. No, I'm sorry. This is the same thing that we just did. The second one is W1 intersection W2. Shinatabra. What was the second part? Where is it? I eat riba. Just give me a moment. I think I have not written this down. Okay, W1 plus W3 intersection. W1 plus W3 plus W1 plus W3 intersection W2 plus W3. Shinatra. Whoa. W1 intersection W2, W1 intersection W2. I am so bad at memorizing stuff ko. I am thina memorize the with se khera kena to iko. Khara why ko adunani aina sida tori se. Anyway, we have got back on track. W3 intersection W2 intersection W3. Sino please try this ko. I notes su yaure. I notes gyan tabra amteng yim yu ko. I think you can clearly understand this from my notes. Okay, so this is a good example. So how do you memorize this? Like I said here, it has more additions. Addition yame yambani na kadoeba contains. Why is it called? Amagi intersection na kadoeba W1 plus W2 intersection W3. Why? Because W1 intersection W3 plus W2 intersection W3. Here it is more number of intersections, more intersections, which implies contained in. Contained in. Oh my God. Contained in. You need this small tricks to help you memorize things. Contained in. So this is there. Addition yambagi contains. Intersection yambagi contained in. Okay. C lower D. C lower D. Okay. Walori. Yes. Some small results. Some small results here. Kashulu dabani. This is the example. Yeah. So if W is a, I think we did this, right? So we will skip this. We will skip this. So the 10th property is if V belongs to the vector space V, and then when you want to say that V plus W is indeed a subspace of V, so that will happen if and only if your V is contained in W. Okay, V is contained in W, right? This will happen when this V is contained in W. And when you for two subspaces V1 plus W and V2 plus W, if you want to have the equality, man is equal or height agadi kay doge habakanda mawani get difference to W V1 minus V2 is indeed contained in W. Eko sa aduga direct sum ki pot sa hapitang nay nasiko. Direct sum height agadi, what is the meaning of direct sum? 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 Direct sum is basically saying V is a direct sum of W1 plus W2. The notation is like this. If number one, V equals to the W1 plus W2, and number two, W1 intersection W2 is basically this. Yeah, because pairwise, it's okay. Pairwise teaching high the intersection contains only the additive identity 0. This happens. Some of the examples of direct sum are this set of Rx is your even function or even polynomials. Direct sum your odd polynomials. I think function and some of the examples are like this. Then what else are the examples? Okay. No isda keno higher kaniko. Odd function the 0 yaw din lak pi ko. Odd function the 0 yaw din lak pi that the wait just give me 1 second. Just give me 1 second. Direct sum 0 the kana ibage. Sida ige ko. R2 is basically the direction of your W1, direct sum W2. What is your W1? W1 is your the one thing that I just wrote here. C belongs to real numbers, and the second thing is 0B. B belongs to set of real numbers. Okay, if you don't like this example, if you are confused about whether 0 being an even function as well as an odd function, so remove this. So this is a better example, an easier example. W1 and W2, they R2 is basically the direction of W1 and W2. Why? Because we just learned that W1 plus W2 is in fact R2, and you intersect W1 and W2, you just get the 0 additive identity 0. Yeah, so this is an example of a direct sum. MNF ke kasu khral laibni ko maduma. I'll come up with more examples tomorrow For now, this is the example. Okay, now coming back, so similar infinite finite dimensionals. This is the explanation of direct sum. This is important for W1 and W2, which are subspaces of V. V equals to W1 direct sum W2 if and only if each of V belonging to this vector space V can be uniquely written as V equals to W1 plus W2. Okay, the uniqueness has to be there. The uniqueness yaudaba yate ko. Sima more property na koi taugra, this we did. And now let us see macam tang hypothetical example ama niding dorm siko. What is this property saying? Mana hai si kaino hypokanda. The dimension of Fn over the field F is basically equal to n times the dimension of this F over the field F. So therefore, you can clearly see here a dimension of C square over R is basically equal to 2 times dimension of C over R, which is 2 into 2 is equal to 4. These are some easy examples. This will come in handy ko hoina dimension puthorpa kanda ko C over R se 2 tabani ko khangdaba kangu ko aduga what is the example last question for the day. Dimension of R over Q. What is this? The question goes to Bubusri. We find the answer to this, we'll wind up our class. Bubusri, please tell me the answer to this. What is the dimension of R over Q? Miss Bubusri, what is the dimension of R over Q? Bubusri yaurika.
Yauri.
Kaino, what is the dimension of R over Q? Then the
Sir, khangde.
Luringamba. Luringamba. Thongamba hangdri ngasigi Mr. Thongamba. Luringamba in Thongamba na bani tana sanagesi anika. Please tell me the answer to this. What is the dimension of R over Q? Luringamba Thongamba. Thongamba yaudabro.
R over Q.
R over Q kisi kya tani luringamba?
Infinite area.
Infinite. Ko no ya khanga to gadi fai but phone the search to madi kitang farak tai ko. Anyway, so dimension of R over Q is infinite dimensional. So please do keep this in mind. In fact, see infinite dimensional this will also be infinite dimensional. This will also be infinite dimensional. But then this guy is finite dimensional. This is one. This is one. In fact, any field over itself has its dimension is basically one. Okay. So please note this down, and tomorrow we'll talk about much more detail. So the classes will be till here for today. Anyone who wishes to have ask some doubts, you can stay back. For others, you are free to log out. So I'll see you tomorrow. Thank you so much.
Sir, basis ki definition do amtang habiyo.
Basis definition. Damtina hayiko. S subset of V is said to be a basis if number one, S is linearly independent subset of V, and number two, linear span of S or say span of S higher linear span the confusion Leibniz. Span of S is basically equals to V. That is S generates V. Example lower toxic. Example lower toxic. Kana example lower. Let's say R2 higher. R2 is basically this XY ka. X and Y belong to the set of real numbers. X and Y set of real numbers. Oh, Flora is here. Okay, Flora is here. Good thing, Flora, you're joining for the doubt session. So R2 says Maintawi. R2 is basically xy. Xy belongs to set of real numbers. All right. I claimed that 1 comma 0, 0 comma 1 is basically a basis. A basis. There are so many bases. A basis for R2. Okay. So that the I need to satisfy I need to satisfy these two conditions. I need to kaha kaya. I need to satisfy these two conditions. The first thing is S is linearly independent subset of V. How do you prove that this is linearly independent? That means you have to take alpha times your elements here. 1 comma 0 is low beta times 0 comma 1 is low mo is 0 equate to bini 0 in this case is going to be 0 comma 0. See low kya aata hai? This is alpha times 0 plus beta times 0. No. Sorry. This is 0 times beta. Linearly independent proof to hai tagadi alpha times x plus beta times y equals to 0 should imply your alpha and beta are both 0. This is linearly independent definition. Okay, I want to get alpha and beta both equals to 0. So this is equal to 0. So here you equate the thing. This is alpha times beta equals to 0 comma 0. This implies that alpha and beta are both equals to 0. So therefore your S is linearly independent. Okay. Now the second question is spanning. S spans your V. What is your V? V is, let's say R2 here. Okay. So your R2 is basically what? You can just say like this, let XY belonging to R2. All right. Then your XY can be written as X times 1 comma 0 plus Y times 0 comma 1. So this is what? The 1 comma 0 and 0 comma 1 they belong to say span of, let's say 1 comma 0 0 comma 1. Okay, so it implies that span of S, that is S generates R2, and hence from these two cases therefore S is a basis for R2. Aduga, there are some properties, some other results. Basis kita ko S is a subset of V is set to be a basis if definition natin ko sina. This is like a result ko. This is like a result. What are the result? The result says number one that the S is the minimum or minimal linearly independent set. Maximum Li and minimum span ko is the maximal high ground. I don't know what maximum high ground for a maximum linearly independent set. Maximal maximum linearly independent subset of V. Surjit, maximum hybrid, maximal hybrid. This is the minimum. How Surjit? Minimum spanning set.
So maximum dum hybrid.
Is the minimum spanning set of V. Okay. O Nikos is there. So sumana P results like S subset of V is said to be a basis if S is the maximum linearly independent set, linearly independent subset of V, or S is the minimum spanning set of V. Yan tayo ko hai se. Haining isi kaino hai kanda si maximum linearly independent hai ta gide khoi na ngasai ki S equals to 1, 0, 0, low ba kana magi dimension se. Dimension se ngasai ki 2 ne ba ko. 2 dagi hen ba kan sida. 2 dagi hen ba kan let's say 3 low se ba ko atopa ti ma ko. 3 low ba kan da C se linearly dependent ta gini ba. 2 dagi hen ba sunga ya de ba ko magi maximum Li habi atha se ko. Yan ta ba hai ja. Khwaidigi chawba linearly independent. Khwaidigi chawba in the sense the dimension ko. Dimension ki matang da mon yaw elements ki matang da ko. Dimension hagira element hagira ko. I think better to say cardinality here ko. because you talk about dimension in case of vector spaces. So it's basically say, you have to say the cardinality here. The cardinality of S, cardinality of T here. Okay. In fact, you can clearly see that if you try to put other terms like this, other terms like this, say 1 comma 1, or any term as you if you want, all these terms they are going to be linearly dependent. Why? Because linearly dependent taga haidi kay ba? Masagi haigibdo alpha x plus beta y plus gamma z equals to 0 oitagati ka at least or say at least one of alpha or beta or gamma is not equal to 0. Amadi non-zero tagadam neba ko. Gyan tay ko haja. Aduna si yang si ko. Let us see whether this is linearly dependent or not. Flora, if you have work, you are free to sign out. But if you don't have, then we'll do this and then we'll wind up. So alpha times 1 comma 0 plus beta times 0 comma 1 plus gamma times 1 comma 1. Let us see whether this is linearly dependent or not. So this is alpha plus line ige. This is 0 comma beta. This is gamma. This is gamma. This is 0. This is alpha. You add this. This is beta. I'm sorry. This is alpha plus gamma. This is beta plus gamma equals to 0. That means your alpha equals to minus gamma and your beta is equal to minus gamma, which implies your alpha is equal to beta is equal to minus gamma. That means you take gamma equals to 1, you have alpha equals to minus 1, which is basically beta. Hybrid decay, no? 1 comma this is minus 1, right? So minus 1 comma 1 comma 0 plus beta is like 1, beta is also minus 1, beta is also minus 1, 0 comma 1 plus 1 comma 1 comma 1 is basically what? Is basically equal to minus 1. Okay, this is 0, this is plus 1, this is 0, this is minus 1, this is plus 1, this is basically your 0 comma 0. Okay, so therefore this is linearly dependent. So this is linearly dependent. So 1 comma 0, 0 comma 1 and your 1 comma 1, they are linearly dependent. Okay, the maximum linearly independent set is contains only two elements. Got two dagi hen by yade. Two dagi hen by yade. Two dagi hen bakanda linearly dependent oy have ka. Yan tayo kasi atumay daw na minimum spanning set su. To busu yan tara to si utade.
Sir, kano independent gidi kyan tayo si spanning set gidi sir.
Okay.
Linear
Spanning
span sa
set.
man gidi sir.
Linear span haidu dum oidoni ko. Spanning set si linear span haidu oidoni. Let me confirm tomorrow. I think basically chapti mana ba poni ko. So jidang wakal kena ilay linear span. Sa manita. Linear span ka spanning set span ka sa manita.
Sir, linear combination.
Okay. So linear span is coming from the linear combinations ko. Aduna manadoi ni ko si se bubushi. Nang adu oidoi bra na trena demonstrate tau haida kind of span to begin na demonstrate amadi tau kada na sida. Kala chakra. Where is that? Yeah. C minus span to haida reko. Linear span do huzik suji na so high reko. Ani se chap manadoi. Why? Because magi linear lai se kada dino high kind of linear combination. Haida reko. Linear combination of the elements in the spanning set. Elements in the spanning set. The word linear is coming from the linear combination of the elements in the spanning set. See if you had any confusion before. And this is how you generate the span. This is how you generate the span. Yeah, bro?
Yes, sir.
Okay. So, Flora, you have doubt? Or you are just here to explore how the doubt session actually looks like? No, sir. Okay, chalo. So that will be all for today, and I'll see you tomorrow. You guys have a great day ahead. Thank you so much.
Thank you, sir.
Thank you, sir.